Hi there. We're going to begin a series on parametric equations, which in our textbook is Chapter 11, Section 7. So this would be after the rotation of axes material, and we're not going to do conics in polar form. I decided I would skip that. There are a lot of topics in this course that are much more than we can cover in a lot of time, so that would not be a major topic. All right, so after parametrics, we'll go into chapter 12, which is systems of equations, Cramer's rule, matrices, things of that type. Okay, so right now we're doing parametrics, chapter 11, section 7. And we'll spend a couple of videos because I'd like to show you how to do it on your calculator, and then we'll look at some theory in a later video, and then finally some applications. Okay, so parametric equations. A parameter is an additional variable used to link two or more continuous functions. Sounds crazy, but that's what it is. Suppose f and g are continuous functions of t on some open interval. This is a parametric equation. Notice we have a separate continuous function for x and a separate continuous function for y, and what we end up with a bunch of points here where the first value is function of t comes in the x, and a second value is another function of t, which would be the y. So what we typically get is we get a path or a curve in two-dimensional space. And if you go on in mathematics, you can also do this, of course, in higher dimensions. Really good applications here. Okay, there is what I'm showing you now on the screen. You can find on Blackboard, so please do this in conjunction with what's on Blackboard. Okay, a couple of observations and properties which are useful and surprising. Y is not necessarily a function of x, so we can extend our ability to graph curves and paths, which we could not do if we limit ourselves to functions. If we're dealing with particle motion, parameter t often has to do with time, and as parameter t goes through its domain of values, a path along some curve c can be traced. And by varying t, we can affect the initial and final position of the particle. We can affect the direction in which the particle is traversed, and we're going to see that in trace. And we can also see the speed at which the particle is traversed. And here dot mode can be particularly helpful. When the dots are further apart, you know the particle is moving more quickly. When the dots are closer, the particle is moving more slowly. So okay, parametric representation is not unique. We'll see this later. And what you want to be able to do, because we're going to be doing a lot of applications, you want to be able to do this on your calculator. So what I've done here is I have laid out the keys you need to press, the applications you need to get to, probably on the T83 or 84 family of calculators, and you need to go through this. If you're not going to do this, then you're going to be totally lost in whatever I do, because I believe that graphing or the pictorial or the visual piece of this is important. Okay, so first thing you want to do if you're on your 83 or 84 machine calculator is you want to select the mode. You want to select PAR, which stands for parametric. You press the Y equals, and what's going to happen is you're going to get something like this: x1 of t, xy, and y1 of t. So don't forget, a pair of these together, right, is going to be defining our parametric curve. Okay? When you press this key, if you're in function mode, you're going to get an x. If you're in parametric mode, you're going to get the t. So here's what we're going to do. We're going to enter x1t is t, y1t is t squared. You're going to press the window key, and you're going to set this up. Okay, you got a T-min, a T-max, and a T-step. So we're going from -3 to +3 on a T. A step of 0.1, so you can figure there's going to be 61 counting 0. We're going to have 61 or 60 dots. Okay, and your X-min, X-max done the same way. Y-min and Y-max, press the graph key, and this is what you're going to get. Okay. If you press the trace key, it's going to enable you to step through the values of parameter t, showing points on a curve for various values of t. The spacing between the points is suggestive of speed. Notice the coordinates appear at the bottom of the screen. Now, if these coordinates appearing obscure or overwrite the curve, then what you may want to do is adjust your window, maybe set Y-min a little bit lower to leave yourself a little bit of room. Okay, you're going to have to experiment with this. Now, one thing you can also do, you can use table set and table commands to produce a table of values. So you have your t's here, and you have your x1 and y1 coordinates here, and you can see what's really going on. So the calculator is a useful tool for doing this. All right. For those of you who don't have an 83 or an 84, I think I posted on Blackboard there is a open software. There's an open app, free, meaning that you can download, have a calculator that does all of these functions. The keys may look a little different, but it's basically all the same thing. I think it's called Desmode or Desmond. I put it on Blackboard for you. Okay. Okay, so parametric mode can often be used to graph relations which are not functions. I have an example for you here, and you would of course go ahead and put this into your calculator. Here are your values of t, and when I give a window, this is the x. So x min is -2, x max is 10, the x means the buy, and a y min is 3, y max is -3, y max is +3. Experiment with the trace. Now, one cool thing that you can do is you can get an inverse by simply flopping or switching what you put in x1 and y1. Okay, you experiment with that as time goes on. Okay, parametric form of the unit circle is this, and if you want to eliminate the distortion to make a circle look like a circle, zoom 5 on the calculator, puts it in square mode. What it does is it changes the aspect ratio of the screen, because the screen is wider than it is tall, and that's why we don't always get a circle. So if you want to use zoom 5, it's going to change some things around for you. Okay, now instructive exercises. These are things you must do. If you don't do these, you're going to be totally lost. I'm going to do some of these now, and I'm going to show you how these graphs look in GeoGebra, but you want to go through all of those. Now, I want you to understand that what I've done is I have put these on Blackboard. It's called Parametric Exercises Solutions, and I've graphed every single one of these for you. I've given you a table of values. I'm also showing you the values of t. So for example, in the first one that we're going to do, it says t starts at -2 and t goes up to 4. So I indicated by dots, well, here, this is the point, t is -2. You got an arrowhead showing that the curve is traversed from t is -2 to t is 4. So we get part of a parabola, and the arrowhead show the direction which it's traversed. Okay, now we're going to talk about inverses, and notice what I did here is I simply flipped the x and the y. So I created a new curve, and what was here the x now becomes the y, and what was here the y now becomes the x. And notice that you get, now starting t is -2, going in this direction, you get the inverse, right? And just to remind you, an inverse is a reflection about y equals x. So I plotted these both for you on the same pair of coordinate axes. So these are the solutions. You will learn a lot by putting this on your calculator, putting uh, putting it in trace mode, and then what you're going to expect it to do is indicate the points. T is -2, T -1, T is 1, T is 2, T is 3 rather, T is 2, T is 3, T is 4, so forth and so on. Make your own table of values. If you do this, you will learn a lot. Okay, I'm going to do a little bit of this in GeoGebra now, and I will have another video which I will have to do on my whiteboard, which is not fun, it's a pain, showing you why this turns out to be a parabola, or why this turns out to be a parabola, or why this turns out to be a line or a line segment, and why this turns out to be a strange kind of curve. Okay, so all of this will be done in a future video, but I want you to understand, unless you do these examples on your calculator and then you look at the solutions, you're not going to learn why these come out the way they do and what the relationships are. In other words, I'm looking at this. Why should this be a parabola? Well, I'm going to show you in a future video, which I'll do on my whiteboard. Okay, why should this be a line or a line segment? And if so, how would you know it's the points it goes through? How would you know the slope? These are things that we're going to look at, and they will be explained later. But it is important for you to go through these, put them in your calculator, and step by step. Okay, if you don't do that, you're not going to learn, you're not going to get the experience, you won't understand. All right, so right now, let me go into GeoGebra, and let's do the first one. All right, the first one says a parabolic segment, so that would be right here. And the way I've set this up in GeoGebra is in the name, I've got the slider. Okay, so we're going to set this up, and by the way, when I change the screen size here, that's equivalent to you on your calculator changing x min, x max, y min, and y max. Okay, so this is number 1, x is t plus 1, y is t squared minus 2t. Now this of course is not on Blackboard because you would require a separate program for this. It's called GeoGebra, Gebra. It's a combination of algebra and geometry, and it's free. I mean, you can download it and goof around with this stuff, and it's free. But at any rate, let's do the first one. So t starts at -2. Whoops. And you can't see the whole thing, so I think what I got to do is I have to move this around a little bit, and this is what I'm doing in GeoGebra by simply a mouse click and moving the screen. And what you would do in order to get this kind of picture and its accuracy in on your 83 or 84 is you would have to change the window. So, you know, let us experiment. Okay, so let's start. T equals -2. You can see how the curve is traversed. And there we go. And you're going to experiment with this stuff, and hopefully you'll learn something. All right, let me turn on the inverse one, and let me shut this slider off. I want that off. Yeah, let's get that away. And the inverse one is in blue. So let me put that slider on. So here's your inverse. Okay. And as I said, you can learn a lot by putting this on your calculator and working through. So this would be example number 1 and 1A. You do it on your calculator. Solutions I wrote up for you, you know, download them and print them out, and it'll be a very cool thing to do. All right, let's look at number 2. Let me shut these off. Shut off that slider. Number 2, I'm looking at here, the way I have it, I have everything sort of coordinated here. So on your machine, of course, you're using T, I use C. All right, so this is number 2, x is sine of t, y is cosine of 2t. And, oh, okay, so my picture is not too helpful, so let me make it larger. And if you're doing this on your calculator, then this would be equivalent to your changing the window. Okay. All right, so let's start again. All right, t starts at 0, and you can see it starts at the point 0, 1. Whoops, starts at the point 0, 1, and it hits here, and it seems to be doing nothing for a while. But if you go into a trace, you will find that what's happening is it's actually going back. So it's going back, and eventually it comes back through 0, 1, and we have a completed, not a parabola, but part of a parabola. So one of the things we're going to have to be careful about is when we learn why this gives us a parabola. I'm going to do that in black and on whiteboard, and a whiteboard, put it up. We're going to learn why that's a parabola, and by looking at the t, it's 6.28, of course, is 2 pi. So you're going to realize why we're seeing part of a parabola and not an entire parabola, and you're also going to realize why it's retracing its path. So if you go to my solutions, you're going to see it all laid out for you very nicely. All right, well, I'm going to have a table of values for t and the x and the y coordinates, and you're going to see how everything is nicely labeled. And we start at t equals 0, so we're starting here. We're going to go down, and then it goes back, and it goes back again. So it retraces its path. This is something kind of cool. All right, and you're going to see that if you go into your calculator and you do a trace. Right? This is very cool. So I laid this out for you, and as I said, you want to label the points, the value of t, so you can tell what this thing is doing, and I'm going to use arrowheads or maybe arrows to indicate the way the path is traversed. And this is something that you need to do in order to learn the material. So let's just look at number 4, which I think is kind of cool. So we'll look at number 4. And where is number 4? Oh, there it is, number 4. And that would be with G. Okay, so this is obviously, I gotta shrink this down, change my window a lot. Okay, so there's my curve, and I'm starting with t equals -2, and I'm going up to t is +2. Okay. And again, you know, what you're going to be doing is you're going to be doing this on scrap paper with your calculator, and you're going to see how the curve is traversed. Notice we have a vertical tangent here, which is kind of cool. And then again, I've got the solutions done for you. And, you know, I even made a table of values for you, and all this you need to do if you want to learn. And you're going to label t is -2, t is -1, here's the point t is 0, t is 1, t is 2, and it's traversed. I put in little arrowheads here in that direction. So please spend the time and go through this, all right? Now, what I've also put up is I've put up parametric equations worksheet. And I've shown you some interesting things here. Now, in most of these are all about the same, okay? X is cos t, y is sine t. So if you take a look at these, they're all variations on the same theme. And what I've changed is the value of t, or sometimes I've swapped the x and the y. Sometimes I put in a negative. And if you do these on your calculator, you're going to learn parameters may be used to vary the initial and final position of our path, whether it's traversed in a clockwise or counterclockwise direction, and the speed at which it's traversed. And I've got the solutions here. It's not as neat as the others, but it's still helpful to you. Okay, so please spend the time, look at the material, and I can guarantee that you will learn a lot about parametric equations. So the next video will be on how we know what these curves are. I mean, how we manipulate the x and y in order to get know whether it's a circle, a parabola, a line segment, or whatever. Okay, so I'll see you on the next video.